let's do another example. Say we have a solution of acetic acid, and it has a pH of 5.0. What is the initial concentration of the acid? So we want to know how much acetic acid we put in the solution that would give us a pH of 5. So we set up our equilibrium equation. So this is the reaction of the weak acid in water. And we set up our equilibrium expression. So we have Ka. So Ka we can look up in a table. 1.8 times 10 to the minus fifth. So what we've been given now is the pH. So from the pH, we can determine the H3O concentration. So the pH will give us H3O plus concentration. So from our reaction that we set up, now we know X because we know H3O plus concentration, because this is going to be X squared over initial minus X, as we saw before. Letting X be the H3O plus concentration, a 1-to-1 ratio. X is also A minus, and HA is going to be initial amount minus X because of the 1-to-1 ratio. X H3O plus, X amount of HA that reacts. So this is our equilibrium expression that we saw before. Now we know X, we can solve for the initial concentration. So we have I minus X is equal to X squared over Ka, and that means that the initial amount is equal to X squared over Ka plus X. So this will give us the initial amount of acid that we put in the solution, and we can find X from the pH. So let's go ahead and do that numerically. So the pH is equal to 5.0. That means the negative log of H3O plus concentration is equal to 5.0. I want to solve for the H3O plus concentration. That's my X. So to do this, I have to take the anti-log of both sides of the equation. And since this is the log base 10, I just raise each side of the equation to a power of 10. So now I have log, anti-log. They will cancel out. I'll take my negative sign over to the right side of the equation. So now I have concentration of H3O plus is equal to 10 to the negative 5.0. So 10 to the minus fifth power. So that's my H3O plus concentration. So that is equal to my X. So I can stick 10 to the minus fifth in for X and solve for the initial concentration. So plugging numbers in, I'll get initial concentration is equal to 10 to the minus fifth squared over Ka plus X, which is 10 to the minus fifth. So that gives me initial concentration of is 1.6 times 10 to the minus fifth molar. So that's the initial amount of acid that was added to the solution to give a pH of 5.